So this is problem number 17 from Unit 3 review, and Mr. Kelly wants to create a rectangular feeding pen for his chickens. He only has 80 meters of fencing, and he decides to use one side of his house as one side of the pen. So if X represents the width of the pen, right here, all right, so we have X there, and therefore that's going to be X as well. All right, express its area in terms of X. The side of Kelly's house is the length. So here, from here to here is the length, and from here to here is the width. All right, well, let's analyze this. What exactly is going on here? So if we want to determine, we are going to have some kind of expression that represents this distance right here, because area, of course, is length times width, base times height of a rectangle, however you have historically looked at that. If we have 80 meters total of fencing, and we've used up X meters here, and we use up another X meters here, that means that what is left for this distance right here will be 80 minus X plus X to X. So that is one way of thinking of it. If you watched some of the videos that have been done for this curriculum, you got a different kind of method of establishing that 80 minus 2x. But if you really just think about the length here is what's left of our fencing if we've used up X meters, and we don't know how long that is, but we can still express it in terms of X. So for problem A here, we're being asked to express the area of the pen in terms of X. So the area equals length times width, base times height, however you want to look at it, would be base, and let's use a different color. Here's our base right here, measured as X, and our length or height is 80 minus 2x. So if we multiply those two quantities together, whatever they happen to be, that will be the area of our pen. Now we can multiply this out and distribute X if we wanted to, and I think that's probably what they want us to do. So area equals 80x minus 2x squared. And if I were to write that in proper standard form, I get negative 2x squared plus 80x. Okay, so that is our equation that represents the area. Now let's move on and take a look at B. What is the domain of our function? And this is going to require us to graph it. I mean, you can kind of approach it in a logical way as well, but let's graph it and see what happens. All right, so if I input this into the calculator, if you notice over here, it might be a little small. I input the equation into the calculator, had to work just a little bit with my window in order to be able to see the entire parabola, but we can see it right here. And the idea is, what are the possible, when it says domain, it's all about the relative domain, okay? So the domain being, what are the possible values of X? Okay, so if I can demonstrate this on the calculator, or we can think about it logically. Let's go to second and calc, and we're going to actually calculate the zero of our graph. So just to kind of make sure that we're kind of getting, so I'm on my left boundary, enter, right boundary, enter, enter, and our zero is actually at 40. So our domain is essentially from where X equals 0, which cannot exist. We can't have a pen with a width of 0. So we would say 0 is less than, can't be 0, X is less than 40. And if we use 40 meters here and 40 meters here, well, then there would be nothing left to create this side right here. We would have a 0. So it can't be equal to 40. It would have to simply be 0 is less than X is less than 40. And yes, you could have like a 0.1 meter width pen. Doesn't make any sense, but it can exist, okay? It wouldn't be logical, but that's what it would have, okay?